And my current role is studying a new technique for realizing future telecommunication system. And so today, I would like to present my ongoing work and get your feedback at the end. Before explaining detail, I show keyword, data debossing development, shown in this figure. In traditional architecture, data and process are coupled. But after data debossing development, data and process are debossed. This is an important keyword in this presentation, so please remember. Next slide, I show a recent trend in telecommunication system integration. A telecommunication system all requires scalability and load balancing, and etc. Of course, this is generally requirements. So developers have to satisfy these requirements. And in production architecture, there are some services. These are examples. Moving data between servers and changing configuration data. And compare sharing data between servers. These services cause a big running cost, but now the virtualization technique offer potential to satisfy requirements without services. This is mean we have potential to reduce the running cost. The next slide, I'll show one of the solutions for satisfying further requirements, shown in this figure. In traditional architecture, each server can only access its own data, and they can process user requests related to the data. This means this architecture is not flexible. But in data debossed architecture, each server can access any data, and each server can process any data related to requests. So this architecture is flexible. And we can, in this architecture, we can avoid some services. For example, in scaling, we don't have to adjust any data on servers. And in load balancing, we don't have to select processing servers. So we can reduce running cost. This architecture is good, flexible and good. So some systems adopt this architecture. And in NTT, there are many transactional type system. So someone is adopted already. And this is not only NTT. Other OSS project team adopt this architecture. But when developer adopt this architecture, there are some problems. Next slide, I explain the problems. One of the problems is request throughput performance degradation. Server have to access external database in this architecture. This accessing external database causes time delay, and the time delay causes performance degradation. So problem one happened. And other problem is here, inability to estimate cost effectiveness. Developer doesn't know the degree of the performance degradation, so they can't estimate cost effectiveness. And they can't decide to start the development. So I think a developer have to evaluate effect of debossing data. Next, I explain background of this presentation. Next section, I will explain my idea about development process. Firstly, I show developers' task determining target debossing data. Systems have large amount of data, and they have different characteristics. So developer have to determine target data. And in SHIP, there are some status data, transaction data, and direct data. Transaction data is more accessed more frequently than direct data. This is because transaction data arises for every SHIP request, and direct data arises for every SHIP call. So there, in this case, also there are different characteristics. Which data should be divorced? I show 3 examples. One is traditional architecture. In this case, no one divorced. And choice B, this case, only direct data divorced. And choice C, in this case, both data divorced. To be more flexible, this choice, both data divorced architecture is better. But performance degradation is bigger than other choice. Because there are trade-off relationship between increasing flexibility and performance degradation. So developers have to determine data, and they have to consider this trade-off relationship. However, the developer doesn't know effect of divorcing data. So developers have to evaluate effect of divorcing each data set. In software, there are large amount of data set. So, but I think target data is global variables in C programming. In C programming, there are also local variables. But local variables should be in specific servers. So I think global variables is target data. This case is developer doesn't know software architecture very well. If developer know the software architecture very well, they can narrow down by eliminating target data. And this slide shows my idea of the development process. Phase 1 is evaluating effect of divorcing. And phase 2 is selecting data to divorce. This phase is by each developer's requirements. And phase 3, this is a typical flow. So I add phase 1 and phase 2. In this development, and this phase 1 and phase 2 is, I think, these are a big hurdle. So I would like to support these phases by my studying technique. So next section, I'll explain the technique. Firstly, I show tentative assumption, motivation environment tentative assumption. Motivation is already explained. Developers have to evaluate the effect in the development. And there are large amount of data, and they have different characteristics. And tentative assumption. I think I can evaluate the effect for all data sets by their characteristics. This is evaluating formula concept. Each effect equal sum of degree, each characteristics degree. But this is only tentative assumption. So I test in asterisk. In this experiment, I prepared 2 asterisk. One is normal. One is data divorced asterisk. In this case, asterisk have to access external database. So then time delay cause and performance degradation is cause. So I times the delay between 2 asterisk system when each data set was divorced. And this is some of the results of experiments. I found two distinctive trends. One is here. Divorcing more frequently access data increase touch delay quickly. This means the performance greatly delayed. And divorcing larger data increase touch delay slowly. In this case, the performance degrades less. So these trends show the effect of divorcing data depends on the data's characteristics. This is some of the results, but my experiment is not finished. I will do other experiment. So, but I think the evaluating formula is this style. I will confirm. I will confirm. And after confirming, I will make two automatic tools. One is evaluating tool, automatic evaluating tool, and one is automatic data divorcing tool. I think these tools can support the phase 1 and phase 2. So I think these tools will enable developers to estimate cost effectiveness easily by trial and error. I conclude the presentation. Data divorcing make telecommunication systems much more flexible, but there are some problems. Developers need to evaluate the effect of divorcing data for estimating cost effectiveness. I propose evaluating technique by using data's characteristics. In result of the experiment, the effect of divorcing data depends on the data's characteristics. I'm doing experiment for confirming evaluating formula. I will make automatic tools. These tools will enable developers to estimate cost effectiveness easily by trial and error. Thank you.
All right, thank you very much, Mr. Yamada. Does anyone have any questions that they would like to ask? All right, I do have a question actually though. The tools that you are developing for evaluating the effectiveness of divorcing the data, are these tools that you will use internally to NTT in the future developments of your network, or will these also be tools that might end up on something like GitHub or some other shared site? Sure. The tools that you will build for evaluation, they will be used internally by NTT. Will they also be made available to other developers outside of NTT?
Firstly, I would like to adopt in NTT. But in the future, I will expand my adopting area.
Thank you very much. Does anyone have any other questions? All right, thank you very much, Mr. Yamada.